Hi, I am making this video to give you some examples of problems you might see as you work your way through the Khan Academy sections today, specifically the second one. The first one's a little more straightforward. So if you know how to do these, you're in good shape for both. I chose three problems because there's kind of three different possibilities for your problems. You know that it pulls from a problem bank, so you might not get these exact three, but you'll get ones like it. If you're lucky, you'll get at least one of these since we're doing them together. So the first kind is super easy once you see what to do, but before that, it might be a little bit confusing because we can see that we have a triangle and they gave us one angle, and they're asking for angle B down here, and it doesn't feel like there's enough information. And so what we need to realize is this isn't just any old inscribed angle. I mean, it is an inscribed angle because the vertex is right there on the circle. But if I trace it out, one of the points is one end of the diameter. The other point is the other end of the diameter. So this inscribed angle is intercepting or cutting a 180-degree arc. And since inscribed angles are always half of their intercepted arcs, that's a 90-degree angle. Now it's a super easy problem. I know two angles in the triangle. I can always find the third one. But before I made that realization about that angle, might have been a little tricky. And I certainly don't want you to make any assumptions. Don't look at this and say, well, that angle kind of looks like that angle. No, you'll get this problem wrong if you do that. Actually find the numbers, don't guess. All right, let's look at my slide number 2 here with one that looks really complicated. Problems like this are a little intimidating at first. I picked the one that looked the most complicated from the problem set so that I could demonstrate with this one. So this is kind of worst case scenario, I guess, as you might look at it. All right, ultimately I'm looking for the measure of angle ISE. So ISE, this one right here. And I'm just highlighting it. I'm not claiming it to be the same as the other ones or anything like that. That angle goes with this arc. If you trace the sides out, it intercepts arc DE, but I don't know arc DE. So this is not a direct problem. I'm going to have to get my answer indirectly on this one. And my best advice to you on a problem like this is just jump in and start finding anything you can, because eventually you'll hopefully get to the point where you go, oh, I see how I can get that one. It's not always an obvious path to take. So when I look at this situation, I see quite a few inscribed angles. And if I know the angle, I can find the arc or vice versa. So first thing that my eye caught was this 27. If I trace it out, it goes with arc SL, and the angle is always half of the arc. In other words, the arc is twice as big as the angle. So arc SL is 54. Oop, that looks like a 6. Let me fix that. There we go. Oop, oop, oop. Don't want to confuse myself later. And that's for the arc right there, SL. The other thing I noticed is that we do have a diameter here, and I'm always on alert about those diameters because this arc over here is 180. So any inscribed angle giving me this arc is going to be half of the 180 or 90. And I can trace it back this way, and I can find out that angle L is 90. Or look at this, I can trace it back this way and find out that angle D is 90. So got 2 for the price of 1 there. Not doing too bad. And now that I know some angles and stuff, I can find some other angles in this picture. If I look at this little triangle up here, for example, it's a right triangle. I just marked that angle. If this angle is 61, 180 minus 90 minus 61, it's going to tell me that this angle is 29. And if I do 29 times 2, look at this. It gives me this arc. And 29 times 2 is going to be 58. for this arc. And all of a sudden I see light at the end of the tunnel because I have a 180, a 54, a 58, and a I don't know. But I can figure it out because all together they make a whole big circle there. So I am grabbing for my calculator and I am doing 360 minus the 180 minus the 54 minus the 58, and I got 68 right here. And so look at that, my angle, because it intercepts that arc, is half of that 68. That's an awful 8. It's not much better. Oh well. And half of 68 is going to be 34. So there we have it. My phone is celebrating. That angle is 34. It took a lot to get there. It may be true that somebody sitting next to me in a classroom or something would say, oh, why'd you do all that? You could just do this. And sometimes we get that. And actually, now that I look at this problem, I see an easier way to do it. But whatever, you can get your problem done your way. Just in case you're curious, here's what I just noticed looking at this. If this angle is 61, 180 minus that would give me this angle. And then I've got a triangle where I know 2 angles and I can find the third one. That would have been a lot easier. But whatever, we did lots of fun math to get there. I do that all the time. After I get the problem done, then I see the easy way. So don't think you're alone on that. All right, and finally this last one. We actually saw some like this when we were doing our inscribed shapes. Excuse me. And what we see in this situation is that we have inscribed angles. And so this 74 doubled would give me this angle. And so 74 times 2 would be 148. Then I could do 360 minus that. 360 minus the 148, and I get 212. That would be for the rest of the circle. And then if I trace it back, this angle that gives me that 212 is going to be half of that 212. So if I divide that by 2, I get 106. Now you might be seeing me do that and saying, why are you doing that? If you remember what we did with our inscribed quadrilaterals, because we figured out that opposite angles totaled 180. I'm showing you why. Opposite angles total 180 because they intercept opposite arcs that have to total 360. And so that's kind of a cool reason behind what we already knew. And so knowing that fact, I don't necessarily have to look at arcs for these two. I can just say, oh, these two have to total 180. And if that one's already 92, then this one must be 88. And so that's the reasoning behind that. That's why it works. I hope these problems help you to have smooth sailing when you get to your problems. As always, let me know if you have any questions. Email, remind message, whatever.